Hello good day viewers, welcome back once again. In our today's video, we're going to find the following given limits. We have the limit as x is approaching infinity of x to the power of 1 over x. Now before we proceed, we're going to recall the property of the L'Hopital's rule, because in this video we'll be evaluating this limit using the L'Hopital's rule. Now, let's assume we have the following limit. Limit as x is approaching a of the following function of x divided by another function of x. So the L'Hopital's rule states that this limit is also equal to limit as x is approaching a of the derivative of the numerator here, that is f prime of x, divided by the derivative of the denominator g prime of x. Okay, this is a very wonderful theorem. I'm going to apply this theorem here because we need to evaluate this limit. Now, this our limit, let's call it I. So if you call that limit I, that is limit as x is approaching infinity of x to the power of 1 over x. Now from both sides, we're going to take the natural log of both sides. So here we have the natural log of I. This will be equal to limit as x is approaching infinity of the natural log of x to the power of 1 over x. Now with the property of natural logarithm, we have the natural log of a to the power of b. This is same as the b, which is the power of a here, multiplied by the natural log of a. So from here we have this as limit as x is approaching infinity. Now the power of x here, that is 1 over x, multiplied by the natural log of x. From here we get the natural log of I. This is equal to limit as x is approaching infinity. So we can write that as the natural log of x divided by x. Now from here we can make use of this theorem here, because we have the numerator here as a function of x and we have the denominator here as a function of x as well. So from here we make use of the L'Hopital's rule. So we get the derivative of the natural log of x divided by the derivative of x, right? So from here we get the natural log of I. This is equal to limit as x is approaching infinity. Now the derivative of the natural log of x is equal to 1 over x divided by the derivative of x, which is 1. So from here this is equal to limit as x is approaching infinity of 1 over x. And we know that the limit of x as x is approaching infinity of 1 over x will give us 0, right? 1 over x as x is approaching infinity is 0. Consider this. 1 over 2 is equal to 0.5. 1 over 4 is equal to 0.25. We can see that the value is getting smaller, right? So as the denominator right over here is getting larger, 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 and larger, the value will be tending to 0, right? So this explains that the limit of 1 over x as x is approaching infinity is 0. So here we have the natural log of I is equal to 0. From here we need to solve for I, right? So here, I will be equal to e to the power of 0, and this is equal to 1. And this is the right answer. So we can conclude that the limit as x is approaching infinity of x to the power of 1 over x is equal to 1. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.